multiplication property of equality. Now, this is going to look really similar. If A equals B, then AC equals BC. And so now, right, in multiplication property of equality, instead of adding C to both sides, I'm multiplying by C on both sides. And so again, we can sort of have this note where we can always use multiplication to become division. And so multiplying by the reciprocal that's division. Multiplying by the reciprocal, that's the division. Right? We see this, and have seen this most recently, with dividing fractions, right? Keep, switch, flip, or keep, change, flip, however you want to think about it. That's really multiplying by the reciprocal. Dividing by 2 is the same thing as multiplying by 1/2. Dividing by 2 is the same thing as multiplying by 1/2. And so the key takeaway, right? First key takeaway we're going to write in here, / I guess second. What these properties of equality really tell us is what we've already been naming. Whatever we do on one side you have to do to the other. Whatever we do on one side, we must do to the other. Again, cardinal rule in math, you cannot break this. We cannot just add +2 to one of the sides and not the other. Does not work like that. Once you have this key takeaway, flip your notes so that I can see, please. Thank you. There. Getting there. There's like 10 more seconds, and we're going to flip. All right. Take a look at example 3. Again, solve for x. You're going to notice all of these examples are solving for x. Raise your hand. What am I going to do on both sides of this right now? MJ? Divide by 3. Now, I want a second hand raised. Why? Eden? Say it again. Start over. Say it again. We have what? Because what? Yes. Specifically, let me have somebody else build. Division is the inverse of what? Charles, louder. Multiplication. And so, when we see, right, this 3x, the implied operation here that we don't fully write is multiplication. The implied operation is multiplication. To undo multiplication, we use division. And so now I'm going to have, okay, again, these will cancel. X is equal to, everybody, what is 12 divided by 3? 4. All right, example 4. Hang on, I'll come back to that question. All right, otherwise it should be off. Example 4. We want to solve for x. Now, listen to the question I'm going to ask. It's not the same as the others. Raise your hand. What is the starting operation that we see on 4? What is the starting operation that we see on 4? Gio. Division. We've named that fraction lines are literal division. We have named that fraction lines are literal division. Now, I'm going to take this one more step and I'm actually going to rewrite this in a form that we need to be comfortable switching back and forth between. X over 2 is the same thing as 1/2 x. X over 2 is the same thing as 1/2 x. Now, I'm still going to think and go about this as division. And so if I'm dividing by 2, raise your hand, how would I cancel that? Eden. Here, hang on. This might be confusing us. I just need us to know. I'll do this. These are the same. That's all. I just need us to know those are the same. So let's go back to this original one. If I have x divided by 2, how am I going to cancel that divided by 2?
So you have to do like 10 over 2.
Not quite. I don't want to put the 10 over 2. Let's think about this. Raise your hand. Let's take one. Let's say the smaller pieces at a time. What is the inverse operation of division? Gabby? Louder. Louder. Multiplication. And so just like in all the other examples, notice, right, the actual number or constant or coefficient, whatever it was, stays the same. And so in this case, I want to multiply now by 2. And so if I have, I'm just going to rewrite this so that we can see the line by line really clear. X over 2 equals 10. I'm going to multiply both sides by 2. Again, this multiplication is going to cancel that denominator. And so I'm going to have x is equal to, forgot my line. X is equal to, everybody, 10 times 2 is?
20.
There it is. And so, down this last key takeaway, much as we wrote that addition and subtraction are inverses, multiplication and division are inverses. Multiplication and division are inverses, right? Again, that means that these undo each other. Much like we just saw, if we see division, right, as Gabby said, the inverse there is multiplication. That's what we need to use. If we see addition, the inverse there is subtraction. That's what we need to use.
Can you scroll back to the top a little bit? Can you get like both table 3, 4? All right, just real quick. One thing I want to kind of help visualize or see. The whole idea is that we're trying to isolate x, or isolate the variable. When we have one of something, when we have x by itself, or the variable by itself, on one side, then we can have it solved based on what's on the right side. If you see here, we had 3x. We ended up with 3 divided by 3. 3 divided by 3 is what? What's 3 divided by 3? 1. And anything times 1 is what? Itself. So if we go back to this one, we have x divided by 2, right? How do we get that 2 over 2? How do we get that 2 divided by 2? Eden? What operation do we do? We multiply. Right? So if I multiply 2 by the top, it's going to give me 2x divided by 2. 2 divided by 2 gives me
1.
The 1x, which is how it's isolated. So just keep that in mind. You're trying to get that 1x when you're solving 4x. Okay.
All right, with that, people have already started to do this. Fold your notes, get them glued in. Remember, you don't need a lot of glue. You got 1 minute. Go.